Atoms and molecules are so tiny. Take this teaspoon for example. If I were to fill this with water, there would be as many water molecules in this teaspoon as there are actual teaspoons of water in the Earth's oceans. That's incredible. So with these huge numbers, with these small atoms and molecules, scientists have come up with a new unit. This unit is called the mole. The mole is spelled like this, and it equals 6.022 times 10 to the 23rd. That is a huge number. To help it hit home a little bit more, 1 mole equals 6.022 times 10 to the 23rd of something. Similar to a baker has 1 dozen, that equals 12 muffins. A chemist has 1 mole equaling 6.022 times 10 to the 23rd. This is known as Avogadro's number. Now where did it come from? This number is the amount of atoms in 12 grams of the carbon-12 isotope. 1 mole of different substances contains different volumes and masses, but it is always the same number of formula units. Here's a silly example. Let's take a mole of human beings and put them on this side of a scale. Then let's take a mole of pencils and put it on that side of the scale. What happens? It's logical that of course 1 mole of humans will definitely be heavier than 1 mole of pencils. Also, the volume of 1 mole of humans would definitely be larger than 1 mole of pencils. The formula unit is the most basic unit of that substance. So for example, silver. The formula unit for silver is 1 atom. Elemental hydrogen. The formula unit for elemental hydrogen is 1 molecule of hydrogen. Remember, this is a diatomic. The formula unit for water is 1 molecule of water. What about copper-2 fluoride? The formula unit for this would consist of 1 copper ion and 2 fluoride ions. We use Avogadro's number, which is 6.022 times 10 to the 23rd, to find out how many formula units are in 1 mole of silver. So, in 1 mole of silver, I have 6.022 times 10 to the 23rd formula units. In 1 mole of copper-2 fluoride, I have 6.022 times 10 to the 23rd formula units. To write out our discussion in mathematical terms, I can write this ratio. 1 mole of silver equals 6.022 times 10 to the 23rd formula units of silver. In this case, I know that it's just atoms of silver. I can also write this ratio like this. 1 mole of silver is equivalent to 6.022 times 10 to the 23rd formula units of silver. I can also just switch that ratio. It means the same thing. So I could write 6.022 times 10 to the 23rd formula units of silver over 1 mole of silver. Here's an example problem where we can use the ratio knowledge that we just talked about. So if the problem states you have 4 moles of silver and it asks you to find how many atoms of silver you have, you know the ratio. You know in 1 mole of silver you have 6.022 times 10 to the 23rd atoms of silver. The numerator and the denominator here will cancel their units out because it's moles of silver and moles of silver. That will leave you with the unit you're looking for, atoms of silver. So now what you need to do is multiply 4 times 6.022 times 10 to the 23rd. 2.4088 times 10 to the 24th. We'll go ahead and round that up to 2.409 times 10 to the 24th. Don't forget your units. This is atoms of silver. Let's do another example. Here's my question. How many atoms are in 3 moles of elemental hydrogen, or H2? Whenever you get a problem like this, you first want to start with what they give you, which is 3 moles of H2. 3 moles of H2, it's asking for atoms, so I know that I need to use my ratio. In 1 mole of H2, I have 6.022 times 10 to the 23rd, I use Avogadro's number, of formula units. Now, what is my formula unit for elemental hydrogen? It's a molecule. That's the most basic unit. So instead of writing formula unit, I'm going to write molecule. Molecule of H2. Okay, so if I end there, these units will cancel out and I'll be left with molecules of H2. But that's not what the problem asks. The problem asks for atoms. What's my next step? I can do one more ratio. I know that in 1 formula unit of elemental hydrogen, or in 1 molecule of elemental hydrogen, I have 2 atoms. Hydrogen. That unit will cancel out with that unit. That will leave me with the unit I'm looking for, atoms of hydrogen. I get 3.6132 times 10 to the 24th. I'm going to keep that to 3 after the decimal point, times 10 to the 24th. What are my units? Atoms of hydrogen. And that is my answer. I'd like to introduce you to the mole map. The problem we just finished gave us moles, but it asked us to convert to atoms of hydrogen. So here we began, moles of H2, and it asked us to convert to atoms of hydrogen. We have to go through each of these steps to get to our answer. So let's review the steps we just did. It gave us 3 moles of H2. We used our ratio. 1 mole of H2 has 6.022 times 10 to the 23rd molecules, or formula units, of H2. So that gives us formula units, or molecules. Then we must use the chemical formula of elemental hydrogen, which is H2. And we can use that ratio to give us the number of atoms. For every 1 molecule of H2, I have 2 hydrogen atoms. This is an example of the hydrogen element from the periodic table. What does this number represent? This number is the relative atomic mass. What is the unit for that? It's atomic mass unit, or AMU. We're going to talk about this number a little bit further. The mass of 1 hydrogen atom is 1.008 AMU. Also, the mass of 1 mole of hydrogen atoms is 1.008 grams per mole. Notice the number is the same, the units are very different. Grams per mole is incredibly helpful in our dimensional analysis in the problems that we'll be doing shortly. Here's another example. The mass of 1 molecule of H2O is what? Look on your periodic table. H2O is made up of 2 hydrogen and 1 oxygen. Hydrogen has a mass of 1.008 AMU, but there's 2 of them. Oxygen has a mass of 16.00 AMU. I add this up and I get 18.016 AMU. Let's just round that to 18.02 AMU. That is the mass of 1 molecule of water. What is the mass of 1 mole of water? The mass of 1 mole of water is this same numerical value, but it has different units. The units are grams per mole. This is known as the molar mass. The molar mass of water is 18.02 grams per mole. Here's the mole map again. Well, now that we know the molar mass, let's add to our mole map. Here's our expanded mole map. Notice that we've added mass in grams, and then you're able to make a ratio with the molar mass. You get this from the periodic table. You're able to convert to moles, and then you're able to continue to atoms if that's what the problem asks.